All right, so real quick introduction for myself. My name is Jason Henson. I am president for Loop One. My background and experience is an engineering practitioner, as a generalist, and also leading groups and teams in telecommunications before I came to work for both SolarWinds and Loop One. So, spent 15 years here at Loop One, doing what we do here, building this business and really partnering with our customer base. As you look and see a little bit about my profile there, I would encourage you to also connect with me on LinkedIn. But have really enjoyed this time, and again, this time here at Loop One has given me an opportunity to partner with our customers and help them carry them forward in their adventure of trying to make IT great. Jeff?
Hi, I'm Jeff Garbus. I am a database geek. I have been one since the mid 80s. I was actually certified to teach performance and tuning on SQL Server in 1989, and that's back when you actually had to have done it before they'd let you teach it. Soaring Eagle is a company that does mostly database consulting and database managed services. Happy to talk to you about that later, but for today, we are simply going to be talking about finger pointing.
Great. All right. Let me introduce you to a little bit more information about who Loop One is. So just looking at across this slide, I'm going to pick out a few key points. And I think the idea here is that we really want to make sure that you understand that, hey, here's what our presence is. Here's what we're trying to accomplish as Loop One. So a couple of things about what we've been able to accomplish. We do have 6 public training classes that we offer. That's a really key point if you are looking to advance your own skills and knowledge. This webinar is great. It's going to be massively beneficial, but we can absolutely help you carry that forward too in our public training classes. So feel free to jump in, enroll in those. They are listed on our website at loop1.com, and we'd be happy to have you there. We, as a professional services company, we have partnered with about 250 of the Fortune 500 companies. We don't specifically focus on large business. We do work with all types of companies of a lot of different sizes and in a lot of different verticals. And so that's given us a really great opportunity to pull from those experiences and bring those into your organization, which I hope we are able to do, in a way this morning as we partner with Jeff to deliver this webinar and this message. We do have a little over 100 employees globally. We are staffed out of 5 different countries. So our headquarters is based in North America, primarily in Austin, Texas. We do have an office in the UK. We do have an office in Ireland and Germany for our EU presence, and then we also have an office in Sri Lanka. All very capable employees, all are full-time employees, and we've got some really great talent in all of those teams. Average experience across our SolarWinds background and our SolarWinds certified engineers, we got roughly about 7+ years of experience in each one of those people. So they've got a lot of really great tenure to bring into the conversations with yourselves. And you will see that we've done approximately 5,500, just a little over 5,500 engagements since 2009 and growing. So, Jeff, I'll let you carry that forward.
Sure. Soaring Eagle has been around since 97, so we're approaching 30 years in business. What we do is help people secure, manage, tune, and visualize their data. So about 60-70% of our business is database managed services, full operational database support 24/7. We are all onshore and we are all expert. Beginners never touch your system. We also do a lot of performance and tuning. We specialize in performance and tuning and scalability. We also deal with crisis resolution, systems down, hey, we've been hit, or we just acquired our 3 biggest competitors and now we're not scaling anymore. Architecture training, we just started a class that we're doing with Loop One, which is performance and tuning using SolarWinds DPA. And we just started our vCISO services, which is Chief Information Security Officer as a Service.
And Jeff, if you don't mind, I'm going to ad lib a little bit here too before we jump into the next slide. So, real quick introduction on the partnership here between our two organizations. As you see, Jeff is part of Soaring Eagle Data Solutions. Soaring Eagle, we met Jeff a couple years back, and we started discussing, hey, what does this look like as far as how can we leverage the talents and really bring the value of what where we see a gap on in our customers at Loop One and help bring the value of having a professional that focuses on database. And we'll talk more about that today too. But as we've gotten a chance to know Jeff and his team, it's given us a chance to really expand and start to look at, hey, how do we meet that customer where they're at and really help them to understand, look, we're not just looking at the problems, we actually look at solving the solution, right? So really happy that we've been able to build this partnership with you, Jeff, and thank you for taking the time to build this webinar with us here too as well.
Oh, it's my pleasure, Jason. You guys have been a joy to work with, and looking forward to a long relationship.
Thank you.
So here we're talking about finger pointing, and the idea is everybody's got problems in the IT world. A lot of people won't talk about it, a lot of people won't admit to it, but the fact of the matter is people have problems with their IT, with performance, people calling and saying, hey, the system is running slow, or it's erratic, or it's not up. And what I've done is I've accumulated some numbers which are coming from the larger think tank. So the numbers here specifically are from Gartner Group, they're from the Forrester Group, and they are some that have come directly from Microsoft. And whereas I don't like reading slides to people, I am going to make an exception right here and talk about the effects of these numbers, because typically when somebody calls and complains about performance, it's not just one call to the help desk and it gets fixed. This gets escalated, and trying to find the right person to talk to is really only the first step in analyzing what the problem is. And if you have 3,000 people in your call center, you don't want 3,000 times 6 telephone calls. What you want to do is get this resolved and hopefully anticipated. IT spends 24% of its time on performance-related issues. One of the things that I like to do is eliminate that 80 number on the right, because it talks about 80% of the mean time to resolution simply spent identifying the problem. So one of the things that we'll talk about over the course of this hour, if 24% of your time is spent on performance-related issues and 80% of that, again, these are not my numbers, these are from the think tanks, is identifying, and if we can identify the problem immediately, then suddenly we're only spending 4% of our time on performance-related issues, fixing them. Next, that 30 number is one that I borrowed from a company that does performance load testing. So what a lot of larger companies will do is say, hey, you know what? Let's run this through test before it goes into prod, which is a wonderful idea. But then they'll try a load test. And if you buy a beer for the people who are doing those load testing and writing that software, you get a couple of beers into them, what they will admit to is that they hope to get 30% of the performance issues with that load testing. They consider that to be very successful. So 70% of the stuff is getting missed. Next number is from Microsoft. I'm not sure if I agree with this one. It says 70% of performance problems are caused by source code, not infrastructure. I don't think that 30% is caused by infrastructure. I actually think it's less, but I think that tuning relating items, and it's not just source code, it's people not understanding how to write code for SQL Server. It is people not indexing properly. It's people not configuring the servers logically properly. I think that number is actually probably higher than 70. And that final number is the number of problems reported by business users. So let's think about that. If we as IT professionals can identify performance issues, people are going to be a lot happier with us. And one of the definitions that I've heard for a great DBA or systems admin is that you never hear from them or about them because everything is running smoothly. The catch is you don't know all the work they're doing behind the scenes to make this right. Jason, you want to? I've added a lot of personal comments on these very hard and fast numbers. You want to?
Yeah.
Want to jump in on that at all?
Yeah, talk to these a little bit from our experience. Here's the thing, right? When we look at these numbers, there's a lot of reporting and communication that comes in from, who your customer base is, right? Which typically is whoever's interfacing with that application. And, you do have to leverage a tool to be able to effectively manage that communication back to the customer base, right?
Yes.
And that's where an ITSM tool can come into play, and that's what our IT teams that are running help desk are really great at kind of front running a lot of that stuff. But to your point there, Jeff, too, I'm excited to see and get into some of the conversation that's coming, because when we talk about the percentage of performance problems caused by source code, one of the things that Loop One, um, it's not one of the things. It's a big part of what we do. We end up talking to these sysadmins that are dealing with both open source and closed source applications, right? And to your comment there about 70% of those performance problems caused by source code and infrastructure, I mean, we can always say, we typically have customers that will come to us and say, hey, we got a problem. We see CPU high. What's the next thing you want to do? Well, it's all virtual, so I'm just going to throw hardware at it. But that doesn't really resolve the problem, because now you've thrown hardware at it, but now we have other consequences that fall on the back end of that without getting into that future conversation. I mean, there's so many of these things that just start compounding, and you really have to go to the heart of the matter. So, yeah, I'm really excited to be able to do that. And I could absolutely validate that these numbers seem very accurate to what we're experiencing and what you're saying there as well. So,
Yeah, and you hit on two absolutely critical issues there, or
mhm.
critical components. One is communication. You need to communicate these things inside and outside the IT component. And the second is that throwing hardware at a problem masks the problem and kicks it down the road, but it usually doesn't kick it as far down the road as you would want it to.
That's right.
Um, so what happens in a lot of environments is that the as you saw, there's a number there that said it's source code 70% of the time. Well, the developers are always saying it's not us. It's the database. The database people are always saying it's not us. It's the network or it's the storage. And that argument goes on. And we've got customers that have or have had rooms dedicated to this argument. They call it a war room. Everybody goes in and nobody comes out for lunch or to go home until they have something to point to and identify. I'm usually called in because there's one or two database people and 30 developers and a SAN team and a network team, and the database guy is outnumbered, and he really doesn't know, or she doesn't know, or they don't know how to identify root cause without knowing more about what the specific complaints are. And sometimes the specific complaints are simply, it's running slow and I can't handle it. And 3-second response time to our 3,000 call center people is not adequate.
Mhm.
Where do you get called in, Jason?
Well, so I mean, we get called in by all types of these customers. I mean, it could be a storage customer, a network customer, or a database. What we end up experiencing a lot of times is that we end up coming into a customer, and they typically are operating in their discipline in a silo. And so you have your network team, and you have your server team, and you have the application team, and you have the storage team, and you have the database team, and everybody's kind of doing their own thing, right? The developers are kind of interfacing, and they're typically a customer of all of these. And so we come in, we identify that, hey, there is a silo, and the silos are a really important part of how an organization comes together, an IT organization comes together, because you built those silos based off of your expertise, and that expertise, when we come into those war room sessions, typically we come to those tables with the data that we have, the tools that we have, right? But those tools are typically reporting per our discipline, and those are typically a component or a part of the story. They're not a part, they're not getting down to the shared answer. The shared answer, to your point, is that root problem. So, yeah, we witnessed the same thing.
Yeah, and again, you used a critical word, which is silos. I mean, the siloing is uh, a serious problem in a lot of organizations, and the lack of communications amongst the silos. So when I get called in, it's almost always because there's a performance problem. Uh, Today, our marketing is good enough that we sometimes get called in when people just need general database support, but If it's a word of mouth recommendation, hey, these guys fix my performance issue, and they can fix yours too. We get a lot of word of mouth. So one of the first questions I'll ask when I come in is, how are you defining performance? Because sometimes the user response time is fine, but they've got these things going on in their batch windows, which started out as 2-hour jobs and are now 8-hour jobs in their 6-hour batch window. And the idea behind what they're trying to do and what they're trying to accomplish is one of the critical components in identifying whether you're successful. Because if you take the CPU down from 80% to 20% and people are still getting 2 to 3 second response time, they're still not happy campers, even though you got those CPU down, percentages down. So we need to be able to look at each of these components in order to be successful with the end result. So performance, as Jason mentioned, isn't always the box, because you can throw hardware at a problem. I have lost count of the number of times a hardware vendor has called me in and said, look, Jeff, my customer just threw $3 million at our problem. It's not getting any faster. I need you to come in and help me protect the CIO's job for spending the money and protect us from a lawsuit, because we just sold them a lot of hardware. We know the hardware is efficient and we know the CPUs are down, but the users are still unhappy and everybody's still screaming. So where is it? Is it the batch window? Is it the preventive maintenance? Is the maintenance not running? And what we find is that the first step we need to do to solve the problem is identify it. I know that sounds stupid, but how many CIOs and CTOs will say, okay, the CPU is high, we'll throw CPU at it. We'll throw memory at it because memory seems strained. Okay, we'll throw faster storage at it. We'll upgrade from the spinning disks to flash storage. And if that's not your underlying cause, sometimes that'll hide it for a bit, but that really isn't resolving the problem. That's throwing hardware at it. Why do they throw hardware at it? Because it's a fast solution. If I can throw hardware at it today, tomorrow everybody's happy. If it is a software solution, I have to figure it out, recode it, retest it. And for some companies, that's a 6 to 8 week window to get that stuff rolled out. So identify the problem, figure out the root cause. That's step one. Then figure out what you're going to tune. Are we looking at a server bottleneck? Is it an IO bottleneck? Is it figure it out? If it's an IO bottleneck, is it because we're doing a lot of table scans? If it is a memory bottleneck, are we filling up memory with those table scans? If it is a physical bottleneck, are we requesting too much information from the disk because we're not indexed properly or because we're bringing too much code in? If it's a network bottleneck, are we bringing 800,000 rows across the network and only displaying 3 of them? And that was an example from experience and not something I'm just pulling out of a hat.
And you mentioned there too, Jeff. You mentioned being able to recode or taking time to recode that, right? But this doesn't just apply to open source applications that we own. This can also apply to closed source applications as well, right?
Oh, absolutely. And identifying problems in third-party software is something that we have specialized in over time. I mean, a couple of our customers are hospitals. What happens in a hospital is this. The cardiac folks say, I need an application that does A. And at that point, purchasing puts out a bid to 30 companies that have software that does A, and they buy the one that's 4 cents cheaper than the next cheaper one, or they'll throw out the lowest one and they'll take the next one down. So you've got an application that's been written. There's 30 competitors. They bring it in, and maybe this only an application only has 30 customers, and the 30 customers are doing something slightly different from what you're doing. It hasn't been tuned properly, or you have a lot more data than those other customers, and it simply hasn't happened on that scale. So coming in and identifying that root cause problem in somebody else's application, honestly, I consider it to be fun. Germans have a word called Schadenfreude. I can't pronounce it properly. Schadenfreude, which basically means taking joy from other people's pain, like when somebody slips on a banana peel and you laugh at it. But I really like going in and cleaning up messes like that. It's a lot of fun for me. So standard approach. Get a problem at the server level. We look at the OS. We see what the CPUs and IO or network are doing. Are they bottlenecking? If they are, why? We interview the users, particularly the ones that are complaining. I call that squeaky wheel tuning. Whoever's complaining the loudest, we start with their stuff. On a SQL Server side, and this is not only a SQL Server solution, by the way, we'll run Profiler, take a look at the queries. Note that Profiler has two intrinsic problems. One is that 10, 15 years ago, Profiler was an auditing tool. You could bring back 100% of whatever is going on. Today, it is a sampling tool. It does not bring back 100% of what's going on. Plus, the cost of Profiler, and this is Microsoft's number, can be as high as 70% of CPU. So if you're running at 90% of CPU and you start the Profiler up, people are going to start calling and complaining. Finally, you fix the queries and then repeat this as needed, go through your loop until people stop complaining. This was my approach 25 years ago. It is not my approach today. What do we look for at the macro level? We look at I/O, network, CPU, throughput. We look for individual poor performers and bottlenecks. We look at memory. That should probably be up on that first bullet item. Cache utilization. Do we have sufficient memory? We will need to look to see whether it's a VM issue or a host issue. Maybe the host is over-configured. I've certainly seen that before. At the micro level, we look at problem queries, look to see what queries are running, what they're doing, how they're performing, look at the plans, look for red flags in the plans, look for indexing, and go from there.
I'll make a comment about that macro level too. So whenever our customers are engaging us, typically, where we found our story kind of starting, and then we end up resolving with Jeff and his team is you've got one of two things happening. We may have end users of an application that are opening tickets and SolarWinds Service Desk and then highlighting that, hey, there's a problem in my experience, and so the help desk will notify the administration staff of whatever application, and they have to go start looking at things, right? That's where we start correlating all of the metrics that kind of say, hey, let's start looking at this experience and let's start correlating down what do we see at the performance of the hardware or the systems, the network that are actually leading up to the experience that this particular user is happening, or experiencing, right? So we will typically take that or take that administrator through an experience of using AppStack and SolarWinds HCO, correlating data between all of these different resources, and that AppStack allows them to be able to look again. It's a place to start, correlating data to understand where do I look to understand where this problem is. But again, what we typically find is that once we start identifying where this is, then we know which data source to go look at. When we have really complex applications using multiple data sources, all of that leads up to the point where we start executing and what Jeff is talking about here.
Yeah, and once again, you have two absolutely critical points, that communication and training. When I was working as a DBA 25 years ago, I had no idea what I/O network and CPU were supposed to be and how they really interacted with the database. So it's one of those things I like to talk to people about as we are moving through, particularly something like a SolarWinds DPA, so that when the DBA knows that it's I/O or knows that it's memory or knows that it's storage, we can take this and demonstrate it back to the appropriate teams and quantify it and show them what it needs to be for us so that we can get that correct. So what is it we find? Sometimes we have a single query that's taking 1.2 seconds. Will people call and complain about a 1.2 second query? Well, they generally won't unless they've had a little bit too much coffee. But sometimes this is running 100,000 times an hour and it's picking up 40% of the CPU. So taking that down to 20 milliseconds has a dramatic positive effect. Sometimes your top queries are spending their time in a lock wait state. That really isn't something that you can throw hardware at. It is something that you do have to spend a little bit of time recoding for, and throwing hardware at it is going to have literally zero effect. Sometimes there's a few queries that are using the same tables over again. They're using the wrong index. We need to tune. So identifying what the specific causes are and where these things are becomes absolutely critical. So Again, hardware, I treat hardware changes as usually masking a problem. Not always, but we'll talk about it. Server config, there are a lot of basic tricks that you can pull white papers down on the web. Make sure that SQL Server leaves some memory for the operating system. Looked at what the effect of your parent, the bad queries, add indexes, does things, but once again, people are calling me because of a specific issue. So up until about 15, I really wasn't a fan of tools. Not vaporware, but shelfware. Showed pretty pictures. They were great for the operating system folks. They were great for operation because they showed that this was that tool, though, to SolarWinds DPA, because that tool was really buggy. I will not tell you what the name is. But with SolarWinds, it is an easy install. It runs, it does what it's supposed to. I've been incredibly impressed with it. I've stopped writing my own scripts to do the things these tools are already doing, because guess what? Every time a new release of SQL or Oracle or MySQL comes out, these scripts and the data collection's got to change a little bit, and now somebody else is worrying about that and not me. For those of you who are interested in the scripts that I am still using, things like identifying missing indexes, creating them, things like that. My blog site, mssqlperformance.blogspot.com. Again, you'll have copies of these slides, so you don't have to worry about writing that down real fast. That's where I keep code that I don't want to have to keep rewriting, but I go there when I've identified what the root cause is. So, things that I like that DPA does, right? And we're only on slide 20 of 47. I'm going to start jumping into examples really quickly. Identify long-running queries, identify blockers, blockees, what is causing the blocking and what's being blocked. What is it the resources are doing? What are the queries doing that are using up all the resources? It also measures things that I'm not used to having to measure as a DBA: memory, network, I/O, and disk speed. So let's start diving into some of these and taking a look at what some results look like. There has been some argument lately about page life expectancy, but I've still found it to be a really good tool, a really good metric to identify whether we have sufficient memory on our box. Page life expectancy, and by the way, most of these examples you're going to see are SQL Server, but the tool does work Oracle, MySQL, Postgres, and a couple of others, Sybase even still. Page life expectancy tells you how likely a page is to remain in cache before it gets aged out. Now, if you look at white papers on the web, and I warn you about white papers on the web, white papers on the web are often something that one person found in the documentation someplace and everybody else parrots. So, as you're looking at white papers, take anybody's white paper with a grain of salt, including mine. If I put something out there, test it. I've got 20 books in print. I've written hundreds of articles, perhaps thousands of articles at this point. Been published in print and books and magazines.
You
And a
literally wrote the
lot
book.
of articles out on the user blogs. But what they're telling you is that they want PLE to be above 600, which sounds like a really good number, because 600 means a page is going to stay in cache 10 minutes before it gets aged out. The catch is, if you look at one of these PLE graphs, what you see is that it bounces all over the place. Why? Because our workloads aren't constant. They are erratic. Sometimes I'm running accounting. Sometimes I'm running preventive maintenance. Sometimes I've got an extra job or 6 or 20 that 19 different people are all deciding need to be run right now. So if you've got one bad query and you've got a PLE of 600, there's a good chance that one heavy query, especially if you have a lot of data, is going to drive this down close to zero. Why is this so bad? Well, one of the things about DBMSs today is that we do not operate on disk. We operate in memory. So the first thing we do is identify the page that has the data on it that we care about. We bring it up into cache, and then we work on it in cache. With physical storage today at near memory speeds, you would think this isn't a problem. The catch is that we have to be in memory. So the process of bringing things into memory means that I'm going to put a page request out to the disk controller. I'm going to swap my process out until the page is available. When the page becomes available, my process goes into the runnable queue and I get the processor or processors back. Why is this bad? Well, if you think about it, that means if I am doing a scan that requires 100,000 pages, I am going to be swapping my process out 100,000 times. Whereas the swapping out process is very fast, that's a lot of microseconds to add up. So let's tune the system, then check PLE, and then ask the question, do I need more memory?
So Jeff, as you're getting into this too, one of the things that our SolarWinds administrators or users are accustomed to seeing as well, making your comment about, your database is now operating from memory, our administrators will look at CPU usage and memory utilization, and memory on a SQL server is just through the roof and consistently, right? It doesn't always necessarily, what we've said is that it doesn't always necessarily mean that that's a problem, but it's the way that it's reported. Can you expand on that a little bit with as you're going through these two slides and talk about really kind of relate that to somebody who's seeing that and trying to understand how do I troubleshoot and understand this application?
Yes, absolutely. And you faded out for a moment, and I believe that you were
Yeah,
asking you to expand upon the idea of when you actually need memory, because it looks like there's a lot of
yes,
memory in use.
that's right.
So if you look at a graph and it says memory utilization, your memory utilization, SQL Server will grab all the memory it can and keep it. So if you've got a terabyte of memory, SQL Server will grab that terabyte of memory and show that terabyte of memory being in use. Now, that does not mean you're experiencing memory pressure. The memory pressure will occur when we need to swap things out of memory a lot. And that's when you'll see things here in the page life expectancy area. Were you looking for more than that, Jason?
No, that's perfect. Thank you.
Cool. The next topic is disk. And by the way, this is a great way of communicating to the hardware guys that you as a DBA need more memory, and this is how you quantify it. Guys, this is where I need memory. I don't have it. This is why it's a problem. Disk queue length. This is how we communicate as DBAs back to the SAN folks that we have a disk queue length problem. So the disk queue length is the number of I/O requests sitting at the operating system level, backed up behind the I/O controller, waiting for the storage to retrieve data back to the operating system. And it's still called disk queue length, even though a lot of people aren't running disks anymore. They're up in the cloud or they're running things at the out of flash storage. But it's still called disk queue length. They'll probably rename it 20 years from now, and everybody will get confused. But in the meantime, Microsoft defines a disk queue length problem, that is to say, an I/O bottleneck, as a disk queue length of 2 for a period of 10 minutes. So if we're averaging, 100 between 9:20 and 9:30, we've got a storage bottleneck. Now, again, we need to finish tuning before we say we have a storage bottleneck and start investing in more storage or faster storage. But when we see it like this, it says, this is interesting because now between, say, 9:25 and 9:28, I can see what was running and go take a look at it. We'll do that in a few minutes because that lets us find out what was creating the huge disk queue length. Note that the I/O issues can also contribute to blocking. The reason it contributes to blocking is because we're waiting so long for the I/O, the processes that are doing the data modification statements, which might run in a couple of milliseconds, make everybody wait for it. So you get a lot of elapsed user time and perceived time. One of the cool things about the DPA tool is that I can find out who is blocking whom And I can follow a blockchain from the topmost blocker to the next one that is being blocked and also creating blocking on down the list. And I can follow that and I can see if it's all the same stored procedure, if it's all the same table, if it's all the same missing index, and do a lot of drill down. The ability to do the drill down and identify which queries are causing this is critical to solving the problem. One of the, I'm going to call it features, one of the SQL Server features that causes a problem. It's a feature because it's a documented bug. I really only became aware of because of DPA 15 or 20 years ago. SQL Server has a concept called a virtual log file, or VLF. Every time you automatically grow a log, you add 4 VLFs to the log. What does that mean? Well, a VLF, in theory, is a way of eliminating the tail end of the log as a bottleneck. Well, if 1,000 people are all trying to commit at the same time and they're all trying to write to the same page, what happens? We're going to wait for the I/O. But if we have 1,000 different entry points for this, well, we've got the ability to say, okay, I'm going to use a different entry point in the log. This is a very cool idea, but here's the catch. If you have too many VLFs, you find that the SQL Server spends more time trying to figure out where to do the write than it does to do the write. There is a gray line somewhere in the 20 to 80 VLF issue, and I'd like it to be closer to 20, where if you get too many VLFs, you will start seeing a lot of wait time associated with write log that has nothing to do with I/O. It all has to do with logical configuration issues. This write log and a lot of the wait states that you'll see in a tool like DPA clue you into things that you might not have been aware of otherwise, and this was a learning experience for me. My current record is 400,000 VLFs. This is for a group that had a very huge log that was all growing at 2 meg per log extension. It's easy to fix. You shrink the log and grow it all at once. So looking at resources, we can see the OS utilization. We can see the memory rate. We can see the disk queue lengths. We can see the page life expectancy. We have the ability within DPA to look at those and rearrange them as we want to see specific graphs, which is very cool. And we can ask the question, okay, well, when the memory started to be a problem, was the CPU a problem? Was the disk queue length a problem? Before we start looking at queries. Now, as we start looking at queries, the ability to slice and dice what was going on is really useful because I can ask the question what was going on between, say, 1030 and 1031. I can get all the way down to the nearest second because that's the sampling rate. Here I'm looking at the specific wait states. Now, DPA famously introduced a lot of people to wait type analysis. Why do we care? Well, if I say select star from a table and there's a million rows of data in the table, there's some amount of time associated with getting the data off the disk into memory, some amount of time identifying what in memory I'm bringing back, and some amount of time invested in shipping that information back from the DBMS to the front end across the network. So I'll have some I/O time, some CPU time, and some network time. If it turns out that all of my elapsed time is network time, there's nothing I can do to tune the query other than reducing the number of rows that are coming across the network, or getting a faster network, which is usually not in the cards. So taking a look at these wait states becomes a critical component to your analysis because you want to find out what is it that's going wrong. We talked about trending, we talked about network issues. I'm going a little faster because I have 14 more slides to cover in less than 20 minutes. On the network side, this becomes really interesting as well. Again, we frequently wonder, is the network a problem? What DPA does is ping the DBMS. It does a select one. So if I'm in the same operations center and I'm doing a select one from DPA to the DBMS, I'm rounding down to 0 milliseconds generally. This is coming back in microseconds. I find also that if I'm going to a VM, any virtual machine, this tends to round to 1 millisecond. So If the network is not a problem, I tend to see zeros or ones across the board here under round trip time. My personal record for in the same data center is 300 to 400 milliseconds. And it turned out that it was a bad NIC card in the host machine plus a bad router. They got those two figured out because after arguing for months, we finally put a tool in. They brought me in and I said, well, guess what? I can guarantee that it's a network problem and here's why. And the hiring manager said, Jeff, thank you. You've proved in 10 minutes what I've been trying to demonstrate for 2 months. Having the right tool with a graph helps communicate what the net cause of a problem is. Signal weights should be about the last one I've got in the OS level. Signal weights are the indicator that your level of parallelism is too high, because even if you have lots of processors and lots of threads, we see here that the CPUs are low in terms of utilization, but the signal weights are high. Well, a signal weight is a process waiting for an available thread. Why are the threads high when the CPU utilization is low? Because I want to run to a high degree of parallelism and I can't get all of the threads I want at once. If I have 24 threads available and they're all running relatively well, if I have two different processes that want 12 threads and I've got a bunch of processes using one, I may not get all 12 threads at once. So we reduce the degree of parallelism and we typically get rid of the signal weights and dramatically improve performance. Now, let's start getting into queries. What queries are the heavy hitters? So when we ask the question, what query is the heavy hitter? We can get a graph of all the queries that we're running in a particular time frame or particular day and ask who was doing the most, rather which query was doing the most, and what was it spending its time doing. In this example, the top query looks like it's performing about half the work that's going on in the system. What is that work? Well, almost half of that elapsed time is write log time. We've already talked about causes that. But a very small amount of time of that is memory slash CPU. That memory slash CPU, that means we're running. The other wait times we see here are latch wait and page latch wait, meaning we're trying to get information into memory, so we are memory constrained. Preemptive, that typically means we're going out to the OS for something. And we can see that of the things that the query is doing, a lot of this is not related directly to the query. So tuning the query itself is not what's going to help us for this environment. What we're going to end up doing is likely needing to add memory and fix the VLF issue. We also have the ability to get query information historically. It can be really important to ask the question, well, was this query running slowly yesterday? How about the day before? How about the week before? Was it running more? The idea here is that we can pick up the number of requests for the query as well as the execution speed and the average wait time. So if I'm running 100 times yesterday and 100,000 times today, it becomes really interesting to ask, what's the average execution time today versus yesterday? If I'm running 100,000 times versus 100 times and I'm still running at 0.2 milliseconds or 20 milliseconds, I'm pretty scalable. If my elapsed time goes up as the number of executions goes up, I'm not so scalable. This is a great way of asking the question, what's going to happen over the time? It's also a great way of asking, did something change since yesterday because my performance is a lot poorer? And by the way, DPA does capture query plans. So if I had a different query plan yesterday versus today, I can look at both and scratch my head and ask the question, what changed? Did we update the stats? Did we not update the stats? Did the volume of data change? The number of executions also becomes relevant. As I'm tuning a system, because usually I'm brought in because things are hitting the fan and people's hair is on fire, I'll ask the question, is this something that's running, well, this one is running 34,000 times an hour. That's a pretty heavy hitter. If it's running once a day, it's probably not as important, unless it's the report the CEO is running and he's the one who signed off on bringing me in. So this is a great way of identifying what's running. Note that it gives me executions and logical reads. Cool thing about logical reads, and Note I figure logical reads versus physical reads. Logical reads is the number of page requests. Note logical writes is usually going to have to do with checkpointing or data modification. So one execution, 41 million, and running at 5 o'clock. We may tell them to run that overnight or go in and fix it anyway. You can also tell by the date on the slide that I've been using this tool for a very long time. Sometimes it's a volume of data issue. Sometimes there's a lot going on. One of the things that I find is that as you start looking at the graphs of queries, what we're seeing here is that the top 8 or 9 queries really are taking an awful lot more resources than all the ones that are sitting down below it. Why is that important or relevant? Well, that implies that tuning 7 or 8 queries, as opposed to tuning hundreds of queries, is going to have a major impact on our system. And the cool thing about this tool is once I've tuned those queries and it's no longer bubbling to the top, I've demonstrated that it's fixed. Plus, when I go to the historical graph and demonstrate that it's running a lot faster, I can also demonstrate that it's fixed. One of the cool things about performance issues is that people will throw a solution to a problem and hope that it's working well. We can prove that it's working well. Here's a before, here's an after. One of the cool things you have to look at with DPA is the scale. Here, the top of the scale is showing 160 seconds of execution time. Here, the top of the scale is showing 5 seconds of user execution time. So this is a week after doing the tuning. Look at the load on the system.
It's massive.
Massive. And do compare Tuesday to Tuesday, right? Because different days change. Here's that same date, and you can see that we're dramatically down. So the load during the day is way down. The preventive maintenance and batch jobs weren't hugely effective, but you can measure apples to apples this way. Here's another fun graph. You can guess which day I came in to start tuning. I started tuning in midday on October 19th. This hours graph, that's overall user experience time. So the overall user experience time on October 13th was over 70 hours. The overall user experience time a week later on October 20th, about 2 hours. So a 35x factor. Again, for a consultant, this is awesome, but even for internal tuners, when people are experiencing issues, it's really nice to be able to say, hey, this is where we are, we fix it. Without a tool, it's almost impossible to identify what's sitting at the top of your list. And even worse, people call in the afternoon and say, things are running slowly this morning. With the tool that's gathering data and allowing you to slice and dice, you can go and take a look at what was going on this morning and ask the question, what were they doing? And I can get specific. What was user A. Jones doing? Well, this is what they were doing. And you know what? Yesterday, the elapsed times were the same. A. Jones was drinking too much coffee, or A. Jones is right. He or she's got a lot of problems.
Yeah. What I really appreciated about the things that you've been showing us here, Jeff, is this tool, DPA, has the database performance analyzer. As you're showing it, what I'm also picking up on is it's very easy to navigate and very easy to understand. You can tell that it was designed by a practitioner, right?
Yeah.
It's somebody who's been in there, who understands what they're doing, who's had to wrestle with these conversations in the past, and has now built a tool to try to accommodate for those things. So that's really cool. Plus, man, as you're showing those before and afters, that I don't see how anybody that is not chasing a 5 nines experience for availability and performance can ignore that. That it really is a key to accomplishing that goal. So, man, that's awesome. Thank you.
Thank you. So we're down to our last couple of slides. We're almost done, and you folks are almost through listening to me, and I thank you all for your attention. This is a new class that we're doing. We did the first class, was it last week or the week before? It is a 3-day how to tune SQL Server using DPA. So we talk about a lot of internal SQL Server internals, we talk about SQL Server tuning, but we also talk about how to use a tool to identify what needs to be tuned, how to get there and tune it. So if you or anybody you know are interested, this is an open training we're doing through Loop 1. The first alpha version of this, beta version of this, was extremely successful. We got some wonderful feedback from the students, and looking forward to the next one.
Yeah.
So at this point, we'll open this up to Q&A. I'll also mention that we are doing free environment reviews for anybody who's interested. Contact Loop One. We will do is set up a free 1 hour, and that's a free hour of my time looking at your system, teaching you about what your system looks like and is doing, going through actual numbers and making real recommendations.
Yeah.
Questions from anybody?
An opportunity to talk to the guy who wrote the book on it, right?
Plenty of them,
Absolutely. Yeah, I'm not seeing any questions coming in at the moment. We've still got a few minutes if you do want to get your questions in. Obviously, if you want to avail yourself of the offer that you can see on screen as well, please do reach out to Loop One. I'll drop the contact details into the chat. No doubt one of our team will follow up with you anyway in due course following today's session, and I can also include details when I send out the recording in the next 48 hours.
And Helen, how can they reach back out to Loop One if they have any questions?
They can reach us at info@loopone.com, and I will drop details for our contact page in the chat.
Thank you.
And yeah, if you do have any questions, obviously do drop them into the Q&A panel now. Well, we have the benefit of both Jason and Jeff live to answer those for you.
Okay, well, thank you all very much for your time. I appreciate your sitting through this hour with us.
Yep, appreciate it very much.
Yeah,
Thank you,
thank
Jeff.
you.
Thank you, Jason. It was
Thank you.
incredibly informative session. Obviously, great to get the benefit of all your years of knowledge, Jeff, and yeah, all that knowledge that's gone into those 20 books that you've authored as well. So really appreciate you taking the time to deliver this webinar for us. And yeah, look forward to the next one. Thank you very much.
Thank you.
Seth, thank you. Helen, thank you.
Thank
Attendees,
you.
thank you.